Hi class, in this lecture here we're going to start talking about trigonometric functions of real numbers, and then the concept of a periodic function we'll talk about at the end of the lecture. And what we're going to do here, you're going to notice I'm going to introduce some incredibly important topic in this class, in this lecture here. And it's going to be the concept of what's called a unit circle. And this unit circle is going to show up a bunch in all the coming lectures. So it's really, really important that you pay close attention to this lecture and master the concepts of these very simple beginning concepts of the unit circle. Okay, so here are the objectives we're going to work through in this lecture here today. So the first is we're going to use a unit circle to define trigonometric functions of real numbers. Okay, so again, here's this unit circle, and it's a very important topic. A very important concept for trig going forward. We're going to spend a lot of time talking about the unit circle, reading a unit circle table. Then we're going to talk about the domain and range of the sine and cosine functions. And then we're going to use even and odd trigonometric functions. And then the last thing we'll talk about briefly is talking about how you use periodic properties. Okay, so what exactly is a unit circle? So initially, a unit circle is an incredibly easy concept to understand. Okay, so a unit circle is a circle of radius 1 with its center at the origin of a rectangular coordinate system. So it's centered at the origin, and it's just a circle that has radius 1, and this is what it looks like. Okay, so the equation of this circle here, okay, it's just x squared plus y squared is equal to r squared. But you know, what did we say the radius was? It was 1 squared, and that's just x squared plus y squared is equal to 1. Okay. And so what we want to do now is what you can kind of see here is I'm forming some type of angle, okay, here. All right, I'm having the initial side be the x-axis, and then I'm drawing, this is the terminal side of the angle here, and I'm defining this angle in here. And what's really great here is when I go back to like the right triangle trig stuff, okay, this radius r is always equal to 1, okay, which is great. All right, so in a unit circle, the radian measure, all right, so we've got to remember what exactly the radian measure is, okay? So the radian measure of a central angle is equal to the length of the intercepted arc, but if you remember, radian measure originally was equal to, so this is the length of the intercepted arc, S, okay? And you would always divide it by t, or excuse me, not t, by r, the radius. Okay, so I'll rewrite that. So it was length of intercepted arc divided by the radius. But in a unit circle, okay, the radius is just 1. So it's just equal to that length of the intercepted arc. And we're going to define that by some real number, right? So it's a length, okay? So the radian measure is just going to be a length, okay? It's this length right here, all right? And we're just going to define that by some real number, and we'll call that real number t, okay? So instead of that s you see on the picture there, we're just going to say, okay, the radian measure of this angle is some real number t. And what's really great here then is, if you think about this, okay, you can redefine the 6 trig functions, okay, instead of, you know, x, y, and r, you can define them just in x and y because r is going to be equal to 1. So you're going to see this on the next slide here. All right, so if t is a real number and p is equal to xy at some point on the unit circle, so again, on the unit circle, okay, so going back, so this is some point here, x comma y, on the unit circle. Then what we have here, and that point corresponds to some t, okay, so some angle t measured in radians. Then sine of t is equal to y. So originally, remember from previous lectures, sine of theta was equal to y over r. But now if t is going to be related to the unit circle, Well, r is equal to 1. So that's where that y just comes from. That means cosine of t then is just equal to x. Remember, it was x divided by r, but again, we have the unit circle, so it's just r is equal to 1. Tangent of t is equal to y divided by x, and again, just so long as x is not equal to 0. Cosecant of t then is just 1 over y. Secant of t is just 1 over the x value. Cotangent of t is x over y here. All right, so let me pick a point on the unit circle, and then let's go through and find the trig functions here. All right, so use this figure. So here I have this unit circle here, okay? And I'm saying, hey, this is a point right here on the unit circle, okay? And it's the point square root of 3 over 2, comma 1/2. And again, if you were to take this point and plug it into the equation here, it's actually a point on it. Like if you take the square root of 3 over 2 squared plus 1/2 squared, that does equal 1, right? Because this would be 3/4 plus 1/4. Yeah. Okay, so this is indeed a point on the unit circle. Let's find the value of the 6 trig functions for that angle here, t, that's measured in radians, okay? So in this case, sine of t, okay, remember this is my xy point. Just look back. That's just equal to the y value. Well, what is the y value of this point? It's just 1/2. Cosine of t. That's equal to the x coordinate of the point. So that's the square root of 3 over 2. What is tangent? Tangent of t, you know, look back. Tangent of t is y over x. So that's 1/2 divided by the square root of 3 over 2. All right, keep, change, flip if you need to, you know, 1/2, remember that, times 2 over the square root of 3. The 2's cancel. You get 1 over the square root of 3, or when you rationalize this, you get the square root of 3 over 3. So then look, going back, cosecant of t. All right, well look, that's just 1 over y. So that's 1 over 1/2, which would be, you know, keep, change, flip, that would just be 2, right? Secant of t, that would be 1 over x. So it would be the reciprocal, you know, the flip of this. So this would be 1 divided by the square root of 3 over 2, which again is the reciprocal. So it would be 2 over the square root of 3. And then when you rationalize that, you just get 2 square roots of 3 divided by 3. And then again, cotangent. That's x over y. So that's the square root of 3 over 2 divided by 1/2. Keep, change, flip, and you end up just getting the square root of 3 over 2 times 2 over 1, cancel, cancel, and you just get the square root of 3. Okay, so let's take another one, all right? And so what I want you to do here is I'm going to go to the next slide. And what you should do is you should pause the video, okay? You know, downloading the slides obviously with this, and try to find this, you know, the value of the 6 trig function. So I've got this other point on the unit circle here, okay? That means my xy point is minus 3/5, comma, minus 4/5. Okay, that's just another point on the unit circle. And so I'm going to be quiet for a second. Hopefully you pause the video and you give it a shot. All right, again, if you didn't want to give it a shot, you know, just to try it, just to see me do it, let me now walk you through, you know, what this is equal to. Okay, so again, sine of t, so sine of this, sine of t, that's equal to the y value, right? Well, what is the y value? That's just minus 4/5. Cosine of t, that's just equal to the x value. Well, what is the x value? 3/5, minus 3/5. Tangent is y over x. Okay, so that's minus 4/5 over minus 3/5. The 5s would cancel, right? The negative negative would be a positive. So this is just 4/3. Cosecant of t is 1 over y, so it's the reciprocal of this. So that would be minus 5/4. Secant of t, it's 1 over x. This would be the reciprocal of this, which would be minus 5/3. And then cotangent of t would just be x over y. So it would just be the flip of this, right? So it would be minus 3/5 over minus 4/5. 5s would cancel, negative negative, you just get 3/4. Okay. Now what I want to do is I want to show you here two tables that are incredibly important, okay? This has the angle measured in degrees, and this one has the angle measured in radians. And this is the more useful one, okay? This is the chart we will use a lot. Okay, so it's incredibly important to know how to read it and how to read it and its applications from it. Okay, so what this is saying is, look, this is our unit circle, and these angles here are the radian measure. So the angle from here to here, okay, from here to here, it has a radian measure of pi over 6, which is also 30 degrees. And then you can see it keeps going. The angle from here to here has a radian measure of pi over 4, or 45 degrees. And what it's saying here, okay, is that cosine of pi over 6 is the square root of 3 over 2. That's what this first part is saying. And then it's saying sine of pi over 6 is 1/2. That's what it's saying. So then you could keep going. Like cosine of 2 pi over 3, that's negative 1/2. Sine of 2 pi over 3, that's negative, that's square root of 3 over 2. And like, let me just show you in your calculator, just so you can verify this, right? So make sure your calculator's in radians. Okay, so look, I want to do sine of pi divided by 6. See, it's 0.5, it's 1/2, right there. So this is like kind of a little bit of a cheat to help you here, okay? So like cosine of 4 pi over 3 should be minus 1/2. So let's try that. Cosine of 4 pi divided by 3. And you can see, got it, it's minus 1/2. All right, which your calculator is also telling you. All right, let's do some, we're not going to focus so much on the degree one, okay? The radian measure is more important here, okay? But I wanted you to have that for reference. All right, so let's talk about how you read each of these. So let's find each of the following. Sine of pi over 6. So you just go back. Sine of pi over 6, of course I already did that. You can see it's right there, it's 1/2. Cosine of 3 pi over 2. So you're just going to keep going. There's 3 pi over 2. What is cosine of 3 pi over 2? It's 0. It's the x coordinate right there, 0. Okay, tangent. Okay, remember what tangent is. Okay, going back. Tangent is the y over the x. All right, so I'm going to go to 5 pi over 6. Let's find 5 pi over 6. It's right here. So it's the y value, which is 1/2, divided by the x value, which is minus the square root of 3 over 2. All right, so let's see. Keep 1/2, change, and then flip. So the 2's cancel. You're left with minus 1 divided by the square root of 3, which when you rationalize this is the square root of 3 over 3. Okay, cosecant. Now if you need to remember this, what is cosecant? It's 1 over y. So go to 4 pi over 3. So you got to find 4 pi over 3 right here. What is the y value? It's minus the square root of 3 over 2. Okay, so it's 1 divided by this. So keep change flips. So this just becomes minus 2 over the square root of 3. Or when you rationalize the denominator, you get that. And so secant is 1 over x. So secant of 7 pi over 4. So you're just going to go back. You're going to say, okay, where's 7 pi over 4? Right here. All right. And secant is 1 over x. So it's 1 over this. So it's the flip of this. So you're going to take 1 divided by the square root of 2 over 2. So keep change flip. This is 2 over the square root of 2. When you rationalize the denominator, you get 2 divided by the 2 square roots of 2 divided by 2. Cancel, cancel. And just get the square root of 2. So even though the unit circle only gives you, looking back, so even though the unit circle really only gives you cosine and sine, you can use it to find any of the other trig functions. Okay, absolutely. All right, we're going to practice in all the lectures going forward. Not everyone, but a lot of the lectures going forward, I'm going to keep pulling up this unit circle. So we're going to continue to practice reading it, okay? All right, so looking at this, the domain of the sine and cosine function is all real numbers. Like going back, you can plug anything into sine. So like, look, sine of negative. You're gonna, I had a little bit of a typo there. Like I put the subtraction instead of the negative sign. Sorry about that. You could put in anything and you'll get a number. Any real number you plug in there. Okay. So like you can take, sine of e, to the 89th power, whatever, anything like that. Okay. A little bit of a typo there, but you get the idea. Any real number you can plug in, you will get this. Okay. So, sine of 568, whatever, something like that. You'll get a number. Okay. So the domain of this is any real numbers. Okay. But the range, like when you look back at my calculator here, like notice that all the numbers that I was plugging in, it seems like they're bounded, right? Okay. It looks like you're never getting anything greater than 1 or anything less than -1 here. Okay, so the range here will always be between -1 and 1. Okay, so for sine and cosine, the domain, all real numbers. But the range, this is important, okay? The range will always be between -1 and 1. And if you look at it, the reason this is when you relate this to the unit circle, all right, the values of sine and cosine never go below -1 and never go above 1, okay, in each side, okay? And when you think about that, that's because, like, if you were to take this unit circle and keep going around and around, right? Like sine and cosine, what I'm hitting at here is they just seem to like repeat themselves. All right, if you keep increasing the arc length, like you take the arc length 1 rotation, 2 rotation, they just keep repeating themselves. And this is what we're going to call a periodic function. All right, before we get to periodic function, I want to talk about even and odd trig functions. So it turns out that cosine and secant are what are called even functions. And it turns out that cosine of negative t is equal to cosine of t, and secant of negative t is equal to secant of t. So like, for example, if you take cosine of -5, and then you take cosine of 5, you get the same thing, okay? Whereas sine, cosecant, tangent, and cotangent are odd functions, meaning that sine of negative t is equal to minus sine of t. Like, watch. If I take sine of -5, okay, notice how that is a positive 0.9598. So if I take sine of 5, I get the opposite sign. Okay, so that's why you need that negative in front of it here. All right, so these are just little tricks to help us remember or evaluate these. Okay, so basically, I don't want, this is not necessarily correct, but if it helps you remember that, when you have cosine of a negative number, you can think of the negative just not even being needed. But when you have sine, cosecant, tangent, cotangent, it's not correct, but if it helps, you can like factor out the negative if that's the way it helps you remember it. Okay. All right, so let's evaluate this. Let's find the exact values of each of these. Well, cosine of negative pi over 3. Remember, cosine even function. So this becomes just cosine of pi over 3. And then what you're going to want to do here is you're going to want to go back to the unit circle, pi over 3 cosine. So that would be 1/2 right there. So this is an odd function. Sine is an odd function. So this is equal to minus sine of 5 pi over 6. All right, so you're just going to go back on the unit circle, look for 5 pi over 6. So 5 pi over 6, boom. Sine here is the y value, so it's 1/2. So then don't forget you have this negative out here. So it's negative 1/2. And then look, for this one here, what you just have to remember with cotangent, and it's okay to go back and look, right, if you forget these things. Okay, so cotangent is x over y. And then also it's an odd function. So this is equal to minus cotangent of pi over 4. So let's go back and look at pi over 4. Pi over 4 is the square root of 2, comma, square root of 2 over 2, comma, square root of 2 over 2. So it's just x divided by y, so don't forget you have this negative, minus square root of 2 over 2 divided by square root of 2 over 2, which is just minus 1. So these will be properties that this concept of even and odd function. These will be properties that we'll use to help us later on in the course, especially when we start getting into graphing. All right, now I want to talk about the final topic here is a periodic function. So a function f is periodic if there exists a positive number p such that, okay, when you take f of t plus p, you get back to f of t. Okay, and this is for all t in the domain of f. Okay, so the smallest positive number p for which f is periodic is called the period of f. Okay, so it'd be something like the function repeats itself every 5 units or every 10 units. Okay, what you're going to notice with periodic functions when you graph them, the graph repeats. Okay, so it might look something like this. This is going to be actually one of the first graphs we redo. Notice how the graph just continues to repeat, like it follows the same pattern here. Okay, just as a little preview. Okay, this is the graph of y is equal to sine of x. Okay, and so what's going on here is it's going to be repeating itself. And it turns out the trig functions are periodic. Okay, they repeat themselves. So it turns out that sine of t plus pi over 2 is equal to sine of t, and cosine of t plus pi over 2 is equal to cosine of t. So what that means is they're periodic functions that have a period of 2 pi. They repeat themselves every 2 pi. And where does that 2 pi come from? Check this out. To go one full rotation around the unit circle, that distance here, okay, that arc length here, that radian measure here is 2 pi. So you'll notice every 2 pi, the cosine and sines repeat themselves. And then it turns out that tangent and cotangent, okay, their period functions are actually every pi. So they repeat themselves every pi. All right. So you can expand on this and say for any integer t, so integers -3, -2, -1, 0, 1, 2, and so on and so on. Okay. Sine of t plus 2 pi n is equal to sine of t. Cosine of t plus 2 pi n is equal to cosine of t. And tangent of t plus pi n is equal to tangent of t. All right. And it's also the same thing here. If you take cotangent of t plus pi n, that's just equal to cotangent of t. All right, let's use this to help us evaluate some trig functions. All right, so I've got the unit circle down there for reference just to help us. Okay, so let's find the exact value of each trig function here. All right. Now watch this. Sine of 7 pi over 2. Like there's no 7 pi over 2 on my unit circle here. But if I write this as sine, tell me if this is okay. If I break this up as sine of pi over 2 plus, okay, or excuse me, not sine of pi over 2, excuse me. Sine of 3 pi over 2 plus 4 pi over 2. Well, what is 4 pi over 2? This right here is just 2 pi. And so look what that means. If I have some value plus 2 pi, it's just equal to the sine of the first part. Okay, sine of t. So this is just equal to sine of 3 pi over 2. So now where's 3 pi over 2? Right here. And that's equal to -1. And like, let's just grab our calculator here to verify that, okay? So sine of 7 pi divided by 2, saying it's -1, but I evaluated that as sine of 3 pi over 2. Look at that. This method works, okay? So then look here, how would you do this next one? Okay, sine of 11 pi over 4. Well, you want to break this up as sine of 3 pi over 4 plus 8 pi over 4. But, well, look, what is 8 pi over 4? Okay. Where does 3 pi over 8 there? Sorry. What is 8 pi over 4? Well, that's just 2 pi, right? So this is just the same thing as sine of 3 pi over 4. 3 pi over 4. Sine square root of 2 over 2. And then hopefully you can see the pattern here, right? So what I'm going to do, I'm going to peel off a 2 pi here. So this is cosine of pi over 2 plus 8 pi over 2. Well, this is 4 pi, right? But going back, what is 4 pi? That's just 2 pi times 2. So that's okay too. So this is just cosine of pi over 2. Cosine of pi over 2 is 0. And let me show you that that works, okay? Look, cosine of 9 pi divided by 2. Okay, so that tells me that gets really close to 0, okay? And then it's going to be the same thing with cosine of pi over 2. Here, cosine of 15 pi over 4, I'm going to break that up as cosine of 3 pi over 4 plus, check this out, 12 pi over 4. But then you go, oh, well, wait a second. That's not 2 pi, right? Like that's 3 pi. So again, you have to be like, oh, well, I have to pick something different. Well, could I do this? Could I do 7 pi over 4 plus 8 pi over 4? Yes. Yes, so that works. That's cosine of 7 pi over 4. Cosine of 7 pi over 4, square root of 2 over 2. I got it. All right, let's just do the same thing with tangent and cotangent real quick. And now remember, tangent and cotangent, their periods are just pi, not 2 pi. So here, and remember exactly what tangent is. So if it helps, remember tan is equal to y over x, and cotangent is equal to x over y, if it helps remember that. So here, I'm going to break this up as tangent, 7 pi over 6. There's no, if it helps, okay, you could actually evaluate this as 7 pi over 6, but watch this, okay? I'm going to write this as tangent of pi over 6 plus 6 pi over 6, which is just tangent of pi over 6. Which, look, right here. If I take square root of 3 over 2, comma 1/2, and then look at 7 pi over 6. Negative square root of 3 over 2, comma negative 1/2. When you divide them, the negatives cancel, and you get the same thing. So this just ends up being the y value, which is 1/2, divided by the square root of 3 over 2. The 2's cancel, and this ends up, just being the square root of 3 over 3 when you rationalize it and work forward. Here, cotangent, I'm going to write this as pi over 6 plus 12 pi over 6. And look, what is 12 pi over 6? That's 2 pi. But it's every n pi, so that works out too. So this is just cotangent of pi over 6. And so again, that's going to be x divided by y. So pi over 6 is right here. So this is the square root of 3 over 2 divided by 1/2, which is just the square root of 3. Tangent of 15 pi, that's weird. So what's really cool about that is you could write that as pi plus 14 pi. And look, it repeats itself every n pi. Well, 14 pi, that means this is the same thing as tangent of pi. Okay, so go to pi. It's right here. So it's y value, which is 0, divided by negative 1, which is just 0. And then this one here, the way I would do this is this would be cotangent of pi over 2 plus 14 pi over 2, which is 7 pi. So that just means this is cotangent of pi over 2. Well, here, pi over 2, it's x divided by y, 0 divided by 1, which is 0. All right, class, I know there was a lot. I know there was a lot to cover in this lecture. It will get easier the more we practice, and we're also gonna use the unit circle a lot in the coming lectures. Okay, so we'll get more practice with that. And then as always, I'm here if you need anything.